Hello dear students, welcome to Paul Chemistry tutorial. Today I am going to discuss one very important topic of ionic equilibrium chapter, that is buffer solution. What I found is around 70% students having some kind of problems in understanding the concept of buffer, in the mechanism of buffer, in solving numericals of related to buffer solution. In this discussion, I'll cover definition of buffer, types of buffer, how acidic buffers are prepared, and finally one beautiful question to make you understand, to identify whether a given mixture is a buffer solution or not. Now, before going to core concept of buffer solution, I wanted to give one nice example. What we do sometimes, we drink sufficient amount of lemon juice, sufficient amount of fruit juice, and you know those are acidic. Even sometimes we eat some basic food also. But question is that after taking acidic food, after taking basic food, do you think pH of our blood changes? Answer is no. At this point, you should know what is the pH of our blood. pH of our blood is 7.4. Plus minus 0.1 is within the range. That means it may be from 7.3 to 7.5. But due to any reason, if there is some drastic change in pH of blood, it may cause fatal situation. So dear student, ultimately, blood is a mixture. What we came to know, blood is a mixture in which you add acid, you add base, pH of the blood does not change. This is the definition of buffer solution. That is, buffer solution is solution in which you add small amount of strong acid, small amount of strong base, even add sufficient amount of water. pH of the solution does not change, is called a buffer solution. And this is the reason why blood is called a natural buffer. Repeating, blood is called a natural buffer. Now, just to understand even more details, let me share my laptop screen. Here I'll share few PowerPoint slides. You'll understand better. Here we go. Definition, we already got. Buffer solution is a solution in which after addition of small amount of strong acid or base, pH of the solution does not change. Fine. Next question is, what are the types of buffer? How many types of buffer? Basically 3 types. Those are: number 1, acidic buffer; number 2, basic buffer; number 3, buffer of single salt solution, and this is also called a neutral buffer. Neutral buffer. The third one is also called neutral buffer. Okay, so 3 types of buffer we got: acidic, basic, and neutral. Correct? Next question is, how acidic buffers are made, how acidic buffers are prepared. Okay, see the statement, try to understand. Acidic buffers are made of mixture of one weak acid and salt of that weak acid with a strong base. What you understood? You have to take 2 things. One, you have to take one weak acid, any weak acid you take, and another you have to take one salt. Salt of what you know? Salt of that weak acid with a strong base. You are taking 2 things, one weak acid, another is salt of that weak acid with a strong base. That is how acidic buffer is prepared. See, examples: weak acid, say acetic acid; strong base, sodium hydroxide. And you know the acid and base will react giving salt and water. Thus the salt will be sodium acetate, which is the example of salt of weak acid and strong base. Am I right? This is salt of weak acid and strong base. It was weak acid, it was strong base. Okay. Another example, carbonic acid, weak acid, strong base. Let me take again sodium hydroxide. Tell me what is the salt? That is sodium carbonate. So it is the salt of weak acid, strong base, and it is carbonic acid is weak acid. Now, how to prepare buffer? Take a beaker, certain amount of water you take, add acetic acid, add sodium acetate, correct? This mixture will be a buffer solution, and especially this mixture will be called acidic buffer, right? And since acetic acid, therefore it is acetic acid buffer. So this is how it is prepared. Secondly, take another beaker, another certain amount of water, dissolve carbonic acid, dissolve sodium carbonate, dissolve them properly. Whatever solution is obtained, that will be an acidic buffer, and this will be specially called carbonic acid buffer. The student, I think you understood. So this is the way how acidic buffers are prepared. One weak acid and salt of that weak acid, just strong base you dissolve, you will get acidic buffer. Correct? Next, the question is, which of the following combinations will make buffer solutions? This is very interesting question. Three mixtures have been taken. Sodium acetate, hydrochloric acid. See, this normally does not seem to belong to our definition. Second one, acetic acid, 2 moles, sodium hydroxide. Third one, of course, belong to our definition, right? Acetic acid and sodium acetate is a salt of weak acid, strong base, and it is weak acid. So these are the options. I'll come to options afterwards. Solution, you see. I've taken the third one. Already you came to know it is a mixture, is a purely mixture of acidic buffer, weak acid. This is weak acid, and this salt of weak acid and strong base. So this mixture, of course, will be a mixture of acidic buffer, right? So from this option, from this point, what you can tell, option A may be correct. Simply B is ruled out. C may be correct, even D. So these option B is ruled out. Okay. Let me consider the second mixture. Second mixture is acetic acid and sodium hydroxide is taken, right? This is acetic acid, sodium hydroxide. Mind, apparently it does not belong to our definition, so it will be a bit difficult to understand whether it is a buffer solution or not. But see, it is weak acid, it is strong base. After the reaction, the product, you know, sodium acid and water, salt and water, right? Now see how much mole of the components of reactant have been taken. Sodium acid, acetic acid was taken 2 moles. Sodium hydroxide 1 mole. Initially this was 0, this was 0. But mind, the reaction is a balanced reaction. You know the stoichiometry. There is 1 mole of sodium hydroxide react with only 1 mole of acetic acid. It means what I'm writing, you see. Moles reacted and produced. This is 1 mole, so 1 mole will react. Here, only 1 mole will react, although 2 moles are taken. So this is 1 mole, this is 1 mole. Of course, 1 mole of sodium acetate, 1 mole of water will be formed. Finally, what are the moles that left in the reaction mixture? See, this was 1 mole and 1 mole reacted. The net amount left will be 0. Here 2 moles, 1 mole reacted, so 1 mole is left. So 1 mole is acetic acid is left. 0 mole, 1 mole, and 1 mole of water. For the time being, you can neglect this amount of water. Amount of water means already have taken, already dissolved in water, you can neglect it. So finally you tell me, what are the composition, what are the components that left after the reaction? These are the 2 components. That means 1 mole of acetic acid, which is weak acid, and 1 mole of sodium acetate, that is salt of weak acid and strong base. Now you tell me, this mixture will be buffer or not? Yes, this is also a buffer solution. Very clear? So mixture 3 will come, mixture 2 will come, And on that basis, option A is ruled out, right? B was ruled out earlier only. Now we have to check with C and D, means whether option this mixture A, I have to check whether it is a buffer solution or not. Now approach is very similar. I think I understood how to approach. Sodium acetate is a salt of that strong base and weak acid react with strong acid hydrochloric, giving sodium acid, acetic acid and sodium chloride. It's a very balanced reaction. You understood the stoichiometry. Now see, amount was taken. Initial moles, 2 moles sodium acetate, 1 mole hydrochloric acid. Initially no moles of acetic acid, no moles of sodium chloride. Okay. Number of moles that reactant and produced according to stoichiometry you go. You can tell me this is 1 mole and this is also 1 mole. But how much mole was taken? 2 moles. So here I'm writing 1 moles of sodium acetate will react with exactly 1 mole of HCl, giving 1 mole of acetic acid and 1 mole of sodium chloride. So finally, what is left? This is the final moles. 1 mole of sodium acetate is left, 0 mole of hydrochloric acid, 1 mole of acetic acid, 1 mole of sodium chloride. Here also this will not interfere our mixture because it is a neutral salt, neither acidic nor basic, it is neutral salt. And ultimately, after the reaction, finally what are the components left? Very easy to understand. 1 mole of acetic acid, that is weak acid, and 1 mole of sodium acetate, salt of that weak acid with a strong base. So dear student, tell me whether this mixture will be a buffer or not. Answer is yes. So this is how to identify whether a mixture is buffer solution or not. Apparently, although it seems to be not belongs to our definition, but right, you just analyze it and you will be able to easily find out whether the mixture is buffer solution or not. And this is the technique. This is the way how to identify whether a mixture is buffer solution or not. So dear student, hope you like my video. You liked my lecture. Please subscribe my channel. You hit the like button. And if you have some query, some confusion, you can go to the comment box. You write your queries. I'll definitely reply you back. Study well, learn conceptually, and stay healthy. Bye.